Okay, everybody. So that's 5 past. We'll get started now. So my name is Andy Turner. I work at EPCC, and I'm leading this course today. Unfortunately, when I've logged on my phone, my camera it doesn't seem to be working. So unfortunately, you can't actually see me, though my screen share is working, which is the most important thing. Welcome to this course which is ARCHER2 for software package users. Just to make sure you understand what we're going to be covering here. This course is aimed particularly at people who are going to be using the ARCHER2 supercomputing service, which is the UK National Supercomputing Service, and is really aimed strongly at that in a practical sense. So we're not going to talk very much about HPC concepts or those sort of things. There's some things will naturally come up as we discuss it. It is very focused on getting people up and running on ARCHER2 itself, rather than any sort of generic HPC training. And it's particularly aimed at people who aren't compiling and building their own applications on the system. Typically, this course is aimed at people who'll be using software packages that are already installed, or they may compile something, but they won't do any actual development or things like that. So the sorts of things we're going to look at include things like what the hardware looks like on ARCHER2 and what that means for people as users, and how we access ARCHER2 and transfer data, what the software environment looks like, and how do you access different software such as software packages, be they modeling and simulation packages or analysis tools and utilities and things like that. How to write job submission scripts and submit them to the ARCHER2 batch system, and some more information about what's expected of users on ARCHER2 and how you can be a good citizen, and then finally a bit of a look at how you can check what you've already used on ARCHER2, how much resources you have available, and things like that. And in general, in terms of requirements, you should have something where you can use to install software, such as an SSH client is the key one here to allow you to connect to ARCHER2 itself. But in terms of prerequisites, we assume for this course that you have used HPC before, and you have used HPC facilities before, so you've already know how to SSH into places. And we'll talk particularly about SSHing into ARCHER2, but we expect that you've already got experience of using SSH, that you know what a batch scheduling system is. We're not going to explain any concepts around what a scheduler is and why you might use it and those sort of things. You're familiar and comfortable using Linux command line. Okay, so all the sort of prerequisites that we expect for this course. So we're not going to go into any detail about introducing what HPC is, what SSH is, and how you use it, other than connecting to Archer. We're not going to talk about what a batch scheduler is. We're going to just talk about how the ARCHER2 one works and practically how you submit jobs to it. And we're going to assume that you know how to use bash, the Linux command line, and that you know how to edit plain text files. So you should expect that you should already know all of these things before attempting this course. I just wanted to make that quite clear so you know what to expect. What I'll do is I'll put the URL, hopefully you can read my screen, but I'll put the URL for this page in the chat, so that you can follow along there as well if you want, because sometimes you'll want to maybe copy and paste things from the course website into your command line, and sometimes it's easier than trying to read my one. You can go back and look at bits that I've already gone past and things like that. In addition, we also have a course chat page, or a course chat document actually is what it is. It's called NEFAPAD. And I'll put the link in there as well. Let me open that up and put it over here. And this is just a collaborative document where we can all chat. Sorry, I put it in the wrong chat. Thank you, Eleanor, for putting it in the right chat. I just realised I was typing the wrong chat. I was chatting the one to the course helpers. So we can all edit this, and some of the exercises we might do might ask for us all to add things to the the course chat, to the collaborative document there. Okay. So as well as myself teaching the course, I have some helpers here with me. I have Eleanor and Creven, who are here to help out if you run into problems or have any questions or things like that that I can't answer. For example, if we run into problems getting you connected to ARCHER2, they should be able to help and can take you away into a separate room, you know, if you're having real problems, where you'll be able to share your screen and work with them to sort those things out. So please do let us know if you have any questions or run into any problems. Please put your hand up. There's a raise hand option, hopefully on the interface, that you can see down at the bottom. And then you can either type, or you can type questions in the chat. We'll keep an eye on that. Or if you raise your hand, you can speak and answer questions that way. Okay, so let's get started right at the start. I just want to say I've done some logistical things and talked about some bits and pieces and what you might expect for the course. The other thing I wanted to highlight is that we do have a code of conduct for the whole service for ARCHER2, which is designed to make working with the service in all its forms, including training and events and things like that, as useful and as constructive as possible for everybody involved, and for in the training to try and foster as good a learning environment as possible. So it sums up, I mean, in general, you know, it tries to encapsulate the golden rule, which is to treat everybody as you would wish to be treated yourself, but particularly in terms of people from, there's lots of people from different backgrounds and different areas and various things here. So we ask that everybody uses welcoming exclusive language, and you be respectful of different viewpoints and experiences. You gracefully expect constructive criticism and focus on what's best for this course as well, and show courtesy and respect to other course participants. And that covers all of us, both people attending and also the people helping out here in this course. If you think something's happened that you're not happy with, then we do have a way of raising these sorts of things around breaches of code of conduct. So please follow them, or you know, if it's not involving me, then you can also raise it with me directly in a private message via the chat interface if you wish. And the way this course is going to work is it follows, some of you may have come across Carpentry's course before, for particularly things like software carpentry and data carpentry. Instead of being separate lectures and practical sessions, there's a set of material and we'll all work through it together in a sort of interactive manner. So often when we get to typing things and logging into ARCHER2 and things like that, then we'll do a thing where I demonstrate it and then we'll all do it together, and we'll try and make sure we set the pace so that everybody so that it's as useful as possible for everybody. You know, our key thing here with this course is that we want to make it as useful as possible to you. You know, so please do ask questions. Please do let us know if we're going too fast and you're not keeping up, and we can make sure it's as useful as possible to you. I've already mentioned the EFAPAD, which is mentioned here, and feedback's really important to us as well, for both within the course for your questions and feedback in terms of pacing and things like that, and also after the course to help us improve the training. You know, but your feedback, both good and bad, is really critical to what we want to do here. So after the course, you'll receive a request for to fill in some feedback. Please do this if you at all you can. It would be it's really useful for us to hear back both on things both good and bad, so that we can make sure we keep improving our training going forward and make it as useful as possible to people. So as part of the setup, as part of the information you originally got from this course, you should have got some setup information from our training administrator, Claire, which asked you to request an ARCHER2 account and go through that. That was on the setup page. The information is also available here on the course page in the setup section, which talks about making sure you have an SSH client and how to get an account on ARCHER2. You sign up for 2 accounts, a safe account and an ARCHER2 actual machine account. We'll talk a bit more about that as we go through the course, because that's usually the sticking point here, is getting people signed up and logged in. But we'll cover that in more detail in a moment. In terms of timings, the course page has an outline schedule on here. Now, I can't promise. So in terms of what we're going to do, I will stop for lunch at 12:45, or maybe even slightly before, depending on timing. And we will not start again until 13:45. Okay, so the lunch break's fixed, so you can plan your day around that, and assume that you're going to have a lunch break from 12:45 to 13:45. Okay. Other than that, the break times may move slightly depending on the pace and how quickly or slowly we get through the material. Okay, so we may shorten the break slightly if we need to, and we may move the start and end times of them slightly, but we will make sure lunch is fixed. At the end of the day, we said we finish at 4 o'clock UK time, so we will do that. There may be a chance, I think I'll try and stick around for at least 15 minutes afterwards in case there's any extra questions or people have any follow-up questions. And if we're finishing early, there's also an extra piece of material where you can go and try some things out, or just ask them questions or have discussions with the helpers and myself if you want to. But we'll see how we go through the day, and we'll get a better idea, depending on what people want and the pace we go at, how well that'll work, and where we'll get to. So before we get started, does anybody have any questions or concerns about where we are before we get stuck into the material itself? No, it's all quiet. I'm assuming people can actually hear me, hopefully, and I'm not just talking into a vacuum. I did test my microphone beforehand, so I'm pretty sure it's working. Okay, so the first section, like I say, is often the trickiest one to get working with people. We're going to try connecting to ARCHER2, and we're going to talk about transferring data backwards and forwards. We try to have the first break straight after the session so that we get a bit of extra time to sort out people's connection problems if they can't SSH to ARCHER2. But I'm sorry, I could just double check where I am. Oh, sorry, I've gone the wrong place. Let me go back and go start right. There we go. Okay, so as you've all used SSH before, hopefully, you should understand that you get a login address for connecting. The login address for Archer is simply ARCHER2. Is simply login.archer2.ac.uk. And when you access ARCHER2, possibly this will be a bit different to many other systems you've accessed. You need both a password to access the system and a passphrase protected SSH key pair. Okay, which when you create your account, you also add the public part of an SSH key pair to do it. So you need these two different factors to be able to access the system. Okay, this is known as two-factor authentication. So you can have two different ways. You may have seen similar but different two-factor authentication when you've needed, say, both a password or a passcode, and then you have, say, an app, or when you're logging into your bank, you might often have a card scanner which you have to use to log in as well. It's the same idea, it's just the factors are slightly different. So in terms of passwords and the password policy for ARCHER2, that's the bit we can enforce. So when you first get your ARCHER2 account, you pick up a single-use password from the safe, which is our web administration service. And the first time you log in, you'll be asked to change it to a password of your choice. And your chosen password has to have the required complexity as specified in the ARCHER2 password policy. So we go and look at that link. On the Archer website, there's a policy about passwords and usernames and things like that. And what we try to do is try to be as flexible as possible here for people, because different people like different types of passwords. So some people like to have very simple things. They can request very simple things, but are very long with just your words. But some people like to just have random sets of more diverse characters. So ARCHER2 supports both of these. So in general, the minimum password length is 18. Okay, so if you had 18 characters, just all lowercase, then you could use that if you want. So you get extra credits for using different mixes of different things. So you can use, a mix of upper, lowercase numerical, extra punctuation characters. And actually what happens is this ends up with your password length being between 10 and 16 characters, depending on the number of different character types used. And there's some additional criteria, such as 5 characters from your password, not the old one. No requirement to use, there'll be no requirement to use multiple character types, and so on and so forth. What this means is you can support a wide variety of different password states. So we have 4 examples of passwords here that you may or may not be able to use on ARCHER2. And if you can take if we take a moment to think about them and think which ones would be good and which ones will be bad, then we can work through them and have a look. So just off the top of our heads, hopefully you've spotted some trends here. And we look at the solution for this. So the first one, which is just my password, is obviously not accepted or a good choice, as it's both too short and it's made up of obvious words, right? I think most people will be pretty happy with that. The second one, which is rainbow llama jumping, is a good choice. It's long enough, it's easy to remember. It's probably a good password choice, because one of the things you want with a password is also it's easy enough to remember, so you don't actually have to write it down somewhere where somebody can find it and steal it. The next one, this is a random set of characters. It may be accepted and it's fine. It's difficult to actually remember and type, though. Of course, if you use a password manager, there's various ones out there, then you could store your password in that, and actually then that sort of level of complexity doesn't matter so much. And finally, horse battery staple would meet the criteria, but it is a well-known example from a popular web comic, which is where Richard discussed password strength, so would not be accepted because it's so well known and out there on the sort of internet. So while actually meeting the criteria, it fails because it's so commonly known across the internet. Okay, so as well as passwords, I said we had to have a second factor to log in, which is SSH keys. You're required to add a public part of an SSH key pair to access ARCHER2. There's various information on generating SSH key pairs in the ARCHER2 documentation. So if I follow this link here, it's very small, so let me make the text bigger. This discusses how you can access it and how all the different things about accessing, but it also discusses how to generate an SSH key pair on the command line to set up for using to log in to ARCHER2. There is information there if you've not already managed to do this. Now I know, because I've seen the account requests come through, that various people have already requested their accounts on ARCHER2 and had it approved. So some people have already generated these sorts of things and may have already logged in. But what we're going to try and do now, the first sort of big sticking point in this course really is try and log in to ARCHER2. So I am going to the way you log into ARCHER2 is use the SSH command with the -i option to give the path to your SSH key pair, to the private part of your SSH key pair rather than the public part, which you uploaded to the safe, and then your chosen username and the login address at ARCHER2. So I'm going to do this with my one. So I go SSH -i. I know that my key pairs are inserts. So I've got that's the private part. There is a public part there as well, which is the bit that got uploaded to safe, which has .pub on the end. And then my username, which for this account is my initials and TA035, which is the project code for this course. And then login.archer2.ac.uk. Okay. So I'll press return. And then it asks me for a password. Now I have to go to the safe and pick up my password. I'm going to do that on my other screen that you can't see. So you can't see all the personal information. It's on safe, but I'm going to go to my list of login accounts on save. I'm going to view my login account password, and I'm going to copy it and paste it into the terminal. The first thing you'll see when you type a password in the terminal, of course, is you don't see any stars, dots, or anything like that. It just, that was me typing. I copy and paste it, but you don't see the prompt change as you type it in. Right? That just doesn't happen. But and then it tells me I'm trying to change my password straight away. So that's my login brackets L, that password. That's the same as the single-use password that I've just used. So I'm going to paste that in again. And then it asks me to enter a new password. And this could be whatever I want to do, or whatever I want to use in here. So let me try something. Okay, so let me change my password. I chose something that was actually, it was just all lowercase, but it was long enough. It was a series of words that connected together that lets me log in. And that lets me log in to ARCHER2 successfully. And you can see my prompt has changed to show that I'm this user at UAN01, which is user access node 01 on ARCHER2. So can I ask everybody to try to log in to ARCHER2? I'll put up a little poll where people can say whether they've been successful or not. If you need help or have questions, please ask them. And you know, if you have problems connecting, we can get helpers to take you into a breakout room to help you out there by sharing the screen. But if they're general questions, then we can answer them here because they're probably generally useful for everybody. So can I ask everybody to have a go at that, please? And we'll see where we get to. Let me put the poll up. Great. Thanks, Dora. Okay, so we've got somebody's having a problem. Queven or Eleanor, would you be able to go and speak to Carmen and help her out, please? And somebody else. Who was the other name? So if your SSH key is stored in the default location, so Damla just asked, I just used SSH, my account name ARCHER2 ACU, sorry, it should be ARCHER2 ACUK, I guess, rather than ARCHER ACUK. But if you just did that and your SSH key pair is in the default location, then that will work. There is a default location on your local system, which is in homes.ssh. Okay, and if it has the default file name there, which is, mine doesn't have one because I don't store them in default way, but by default it asks you to create a key pair with something like that. Probably if it's in that default location, you don't need the -i option to SSH, and it may just work. That's the equivalent of doing this full command, which would be SSH -i // oops, I can't spell, SSH ID _RSA, for example. So it knows that this is the default location for the key, so just puts it there. So just substitutes that in as required. But because my key pairs in a, oops, and not in the default location. I have to specify with -i. Carmen, yes, permission denied. Hopefully one of the helpers can help you. That usually means that there's something wrong with the SSH key. That either you need to specify the location of it or it's not correctly registered for iSafe. That's usually the permission denied. It usually indicates something wrong with the SSH key. Okay, so I think most people yeah. Okay, so permission denied is almost always something with the SSH key. So hopefully the helpers can come and help you out with those issues. So we've got Carmen and Eleonora who need help, and Alexandros as well needs help, I think. Okay, so what we'll do, we had quite a few people who had logged in successfully, and I know there's a few people who still need help with that. That's fine. Hopefully the helpers can help you out in the background while we carry on here. What I'll do is I will move on with the material and talk a bit about data transfer, and then we've got the break coming up straight after this session. So we'll use the remaining time in this session to help people out, and if we need to extend into the break to help people get logged on as well, we can do that too. So I'll move on just now. Don't worry if you haven't managed to connect just yet, because we don't need it really in anger so much until the next session after the break. One of the reasons we want to get this bit in early is to give us a chance to understand how many people are having problems, and to give us a chance to help them out before we move on with the sessions where access is really critical to making the course work. So the rest of this session's is mostly actually a bit of a chat about data transfer and what options you are and good practice for that. So you don't actually need to log in for that to complete that, but we'll make sure we've got as many people logged in and set up as possible before we move on to the next sessions. So okay, fine. So what I'll do is I will hopefully the helpers can help you out, and I'll put the poll back up again once we get towards the end of the session, so we can see where people are, and then I can help out as well during the break with people when I'm not just talking. So let's get on and talk a bit more about data transfer. So hopefully, as you've used HPC systems before, you've got some idea of how to move data backwards and forwards. Generally, the two methods, most data, almost all data on ARCHER2 moves on and off the system using SCP, or using rsync, which actually uses SCP under the hood to move things anyway. So it's all SCP, it's just rsync adds some nice tools on top to do it. We also support, though we don't talk about it much here because it's not used by very many people, we also support grid FTP if people use grid certificates, and that allows for sort of parallel fast data transfers, but it does require people to have an additional type of certificate, which is called a grid certificate. And I think SCP also support, grid FTP also supports SSH protocol, but it also requires you having another end of the transfer which has all the grid tools installed. So it's not as widely used as SCP, which allows you to transfer data between any systems, either other HPC systems or between ARCHER2 and your laptop or workstation or whatever it is you're using locally. There's a whole section in the user and best practice guide around data management and transfer, but we'll highlight some of the most important parts here in the course. I mean, the first thing I think, before I say anything, is that, or it's the first point here, it sort of ties into the first point here, is that understanding what your data looks like that you're going to be transferring on and off a remote system is sort of critical generally for people. Before you even start running jobs or using the HPC system, knowing what sorts of data you're going to generate, how much of it is going to have to move to somewhere else, or what sorts of data you need to upload before you can actually start using the system is absolutely critical, right? Because what you can imagine the situation that might happen where you get access to a powerful HPC system such as ARCHER2. You're doing lots of work using software packages, lots of research, generating lots of data, and then your access time comes to the end, and suddenly you've got, I don't know, terabytes, potentially even petabytes of data you need to transfer, and it suddenly becomes a very big headache because you have a certain amount of leeway at the end of your project on the system to get off the system. On ARCHER2, it's generally around 3 months, and that time might not be long enough for you to transfer the data, or you might run into problems with data transfer, or you might not have enough local storage to put all the data you want to keep on. So understanding where you are and what your data looks like before you even start is really, really important. And it's not, it says here, for example, know what your data looks like, which is critical data, needs to be copied to a secure location. Generally, an HPC service such as ARCHER2, although some parts of the file systems may be backed up, it's not really a secure place to keep your data because it has a finite lifetime. ARCHER2 will live for 5 years or 6 years or something like that, and then it'll be switched off. All the data on it will disappear at that point. Okay, so it's not a secure long-term place to keep data. Which data do you need in a different location to analyze? Be that analysis on your laptop workstation, be that analysis on another institutional facility you've got access to, a slightly different HPC facility, or even in commercial cloud. So you may use, for example, AWS or Azure to do your data analysis. Which data would be easier to regenerate rather than transfer? Which data is it actually? It's better to just get rid of it because it takes up too much space, and if the worst happens, then just rerun the calculation and regenerate that bit of data. And it says here, create a big data management plan, laying this out as it helps you understand which tools right. And that's true, right? But I think people often, when they see something like write a data management plan, think, oh no, I don't want to do that. That's like pages and pages. I want to get on my research. I want to, I've got exciting and interesting things to look at. But the data management plan doesn't have to be reams and reams of paper. It can just be a series of bullet points on one side, A4, which is the type of data you have, which needs to be moved, which doesn't need to be moved, and how you're going to move it and where you're going to move it to, and things like that. And thinking about that before you even start actually avoids so many headaches down the line. And if you only take one message away from this whole section of the course about what to do around data transfer and things like that, that would be the message I'd want you to take, which is think about the data before you even start. It may be that you think about it and you go, well, actually, I've got no big problems with data at all because I put, I'm doing some sort of quantum chemistry, for example, and my input files are small. They're just a geometry, a Z matrix or something like that. And my output is just the value of the energy at the minimum, or at this point along the reaction pathway. So actually the data is small in and small out. That's fine as long as you've thought about it beforehand, and you understand it. But taking a small amount of time, half a day or a few hours, to think about your data before you start is really very important, and avoids a lot of headaches further down the line. Because this is the whole point of research, I guess, is that you're generating data, you're generating knowledge, and you need to be able to reproduce it. And you're always going to have questions in the future you want to ask of your data that you hadn't thought of when you started doing your work. So understanding what your data is and what's important for those sort of questions is really critical. However, having said that, there are some other useful tips around data transfer, and one of them is minimize the data you're transferring. Transferring large amounts of data is costly for both researcher time and actual time. Managing a large data transfer is pretty full on and can take a lot of time, because often they'll have to be split into chunks and reformed at the other end. You may find that the connection of the place you're transferring it to is a little unstable, so it stops halfway through and you have to actually pick up the pieces and restart, or do it in a way that can be restarted. So rather than try to do everything, which is often the easiest way to think about it, thinking about transferring only the data you need to transfer, rather than going for the brute force approach, can make a huge difference, both in your actual time as well as the transfer time itself. Minimize the number of files you're transferring. So this isn't quite the same as minimize the amount of data, because you might have to transfer all the data, but it might be in thousands and thousands of files. Well, you can combine those files together into an archive, a single larger archive file, because every time you transfer a file, there's a static overhead in the data transfer that takes to sort of set up the transfer. And when you multiply that by thousands, tens of thousands, potentially millions, people could generate a lot of data on an HPC system, a lot of files very quickly on an HPC system. Then you suddenly have the fact that the reason the data transfer is going so slow is not because the amount of data you have, it's the sheer amount of files and the sum of all these different static overheads that come together to make it unmanageable. So you could convert. The trick there then is to merge them together into a single archive file. And there's various tools to do that. We'll talk a bit more about that in a moment. Does compression help or hinder? Right. So often the tools you're using, for example, rsync, but also the archiving tools, which we'll talk about, tar and zip, encourage you to use compression to reduce the data volumes. But some cases, the time you spend actually compressing the data, the algorithm to do that, takes longer than actually transferring the uncompressed data, particularly when you're transferring not between, say, the HPC system and your laptop or workstation, where you might only have Wi-Fi connection for the last bit, or a wide connection that's not got very high bandwidth. If you're transferring between two data centers, or between a data center and the cloud, then you often have high bandwidth, and actually the time-taking compression can not be worthwhile. You're better just transferring the uncompressed data. And be aware of encryption overheads. When you're transferring data using SCP and rsync, generally runs on top of SCP, your data is encrypted, again, with a static overhead per file. As before, reducing the amount of files by using archiving helps, but you can also use a different cipher. Generally, the default cipher used by things like SSH and SCP is not the optimal one. Usually, at the moment, the tests we've done, something like this AES1128 -CTR cipher is the best choice, or is the best choice to use, often because these sort of things are implemented in hardware in the processor and can be very, very fast, whereas the default ciphers go through software and are a lot slower. So, going back to that, you can look at this documentation up here, and it has lots of tips about how to compress data, how to archive data without compression, how to verify that the archive you've created is valid, which is always something you'll want to do before deleting the original data. And there's a question here about, find the command used to create an uncompressed zip archive of all data in a directory with some name. What command you'd use to verify that the archive file you create is not corrupt, so you can safely delete the original data. We'll go get you to just read documentation, because that's not generally useful, but it isn't generally useful during a course. But the right command is zip -o says -0 says to make it uncompressed. -r means to do it recursively. That's like go down the directory and get all of the files. So this sort of command of zip -0r, the name of the zip archive and the directory you want to attach, would create the uncompressed archive for you. And then to verify the archive is valid, you can use the zip command again, but this time pass the -t option and give it the zip file, and it will go through the archive, checking that the data is intact and is not corrupt. So once you've done that and you're happy with your archive, you can delete the original data. Okay, because it's one of the challenges, I guess, with uncompressed data is that the archive takes up exactly the same amount, maybe even a little bit more space than the original data. So you'll want to get rid of the original data at some point, or quickly transfer the archive file out. Okay, so that's been a quick tour through. If you look at the documentation that we linked there about the data transfer, it also tells you how to work with something like tar, which is a standard Unix utility for archiving data, and how to use tar to create archives, how you can then compress those if you really want to, how you can verify the contents of a tar archive are not corrupt, because tar doesn't have an inbuilt tool to do this in the same way as zip does. Okay. So, well, as I said, the key takeaway from the data transfer thing is think before you start your work about what your data looks like, what type is, and which bits you need to keep, which bits you can throw away, which bits you can regenerate, and which bits you're going to have to transfer elsewhere. And then you can make a decision, an informed decision about how you transfer this data and how you manipulate that data to make it useful, make it ready for transfer. So it says at the bottom here, the key points are that the login address for Archer is that. Okay, we'll stop now and make sure we get everybody logged in. Password policy we talked about right at the top, and SSH keys we talked about a bit as well. If you see that permission denied error, that usually means there's a problem with the SSH key somewhere, either in terms of it's registered or you're not specifying the path to it. And there are a number of different ways to transfer data to from Archer. Generally, they all use SCP. I've mentioned good FTP as well briefly, and there's some useful tips on thinking about your data and manipulating your data when you're transferring it. So, before we go on, I just want to check what questions people might have about data transfer and SSH access. Is there anything general people want to ask, rather than sort of the standard, rather than a login problem, which we'll talk about specifically just now? Okay, so I think we've got most people back now, and it's after 20 past, so we'll get started. On the next section and see where we get to before lunch. Let me stop this poll so that we can see what's going on. Okay. So so far we haven't we talked about, obviously we talked about connecting to ARCHER2 and logging in, and we've talked about data transfer. Sorry, Session has a question. He asks, are accounts available after the workshop, or are they going to be erased? So the project you're in, your access will continue after the workshop for another 3 or 4 weeks. Okay, and you'll get a notification before the accounts are shut down to give you a chance to transfer any data off them before then. But the idea is, with the course, I probably should have said this at the start, is that you get a chance to come here and learn about ARCHER2 and what it can do and how to use it, and then you get a few weeks afterwards as well to try out the system and to work to try some things out, because obviously you don't get enough time during the day to actually try everything you might want to try. If you have question, if after trying out the accounts and exploring some things and trying to run some things on ARCHER2, you run into some issues or have some further questions, that's no problem whatsoever. You can probably the easiest way to ask is to get in touch with the service desk. The details on the ARCHER2 website. We'll point them out at the end of the day as well. And you can ask questions there. If you say you were on this course, then they can either just answer your question if they know the answer, or if they have further things, they can always point the questions at me. The service desk know that I was running the course, so they can forward the questions on to me for people. So please, you can continue to use the accounts. Please do use them and make use of them. And if you have any questions, just let the service desk know and they'll get passed through as required. Okay, so we talked about transferring data and data management really. Next, and then before lunch, we're going to have a look at 2 things. We're going to have a look at the ARCHER2, the sort of setup of the ARCHER2 system, that's the hardware, how things are connected together, what that means for users. And then we'll have a closer look at the software environment and how we access software, different software on the system, and change versions and those sort of things. And then we'll finish with a lunch break before in the afternoon we come back and do some more sort of I guess interactive use of the system, we have a go at submitting some jobs and trying those things out before delving into a bit more detail about how you get support and things like that. So in terms of the system itself, ARCHER2 I've mentioned a few times. There's the service, the ARCHER2 service, and then there's the actual supercomputing system itself. Service consists of lots of things, including this training that you're doing now. There's service desk. There's all the people required to support the people running on the system. Support for people asking questions, installing software, and there's always also an outreach component and various bits and pieces. But in terms of the actual hardware itself, the supercomputer that sits at the center of the ARCHER2 service, this is an HP Cray EX system. And it has lots of different bits of hardware put together, but only a few of these really are of interest to users at the moment. And the two things probably that are of interest to users are the login nodes and the compute nodes. The data analysis nodes aren't online yet because the service isn't fully operational yet. They'll be coming online hopefully over the next few months. The other thing we're going to talk about in this section is the file systems and where you store your data. But we'll talk about the actual the nodes first. And in terms of, I said we were going to go into conceptual stuff, but people call things use different terminology. So I'll just say what I mean by node here. So a node essentially corresponds to an individual computer. As all HPC systems or supercomputers, ARCHER2 is made up of lots of individual computers connected together in a particular way. And each node corresponds basically to a physical computer with processors, with memory, and generally with not its own local storage. The storage, as we'll see here, comes from networked file systems that are available across lots of different nodes. Okay, so the two ones that are of interest to you probably are login nodes and compute nodes. All of the nodes on Archer, all the computers on Archer have the same processor type. They're all equipped with the AMD EPYC 7742 processors, and all of them are dual sockets. They have two of those processors in the system. Each of those processors has 64 cores, so every node on ARCHER2 has 128 physical cores. Okay, so they have quite a lot of processing power attached. There's a sort of schematic diagram that sort of shows how things fit together. As I said, the data analysis nodes aren't quite there yet. Neither is the solid state storage. Both of those things are coming online over the next few months, so we're not going to really talk about them very much. So as you've seen, you users interact with the system directly by SSHing into a node or a computer. So when we log in to ARCHER2, we're accessing one of the login nodes. In HP terminology, these are known as UANs, user access nodes. So let me log in again. Oops. So we can show you a bit more about a login node. So my username was, oops, can't spell. So there we go. So now I'm on one of the login nodes. So my interactive shell is on one of the login nodes, and I can see that it's got the type of processor I described with the LSCPU command, which shows me the type of processor on the system. So hopefully, sorry. And the login nodes have a slightly different processor. I should have said that. That's a mistake in the material. I'll need to fix that. It still has 128 cores, but it's a 7702 rather than a 7742. It's a slightly slower processor used for general access rather than for running compute jobs. But you can see it's an AMD EPYC 64-core processor, and yeah, that's right. It's got the same. I'll make sure the material is updated to take account of the fact that there are different processors there. Okay, so that's us sat with our interactive shell and the login nodes. I'm my home directory. I can of course use the pwd command to show you what my home directory path is, and you can see it's home TA035 TA05, and then my username. That file system on home is called the home file system, and it is only available on the login nodes. Okay, Access to the other types of nodes, the compute nodes, is mediated by the batch system. So you can't directly log into them. You have to submit a batch job to get access to resources on the compute nodes. In terms of where we are at the moment with the system, because the system's still in its commissioning stage, there's a smaller number of nodes available than we will be on the final system, hopefully later this year. At the moment, there's 1,024 compute nodes on the system. So each of them has 128 cores. So that gives over 128,000 compute cores on this 4-cabinet system. And all of them have 256 gigabytes of memory per node. All of the compute nodes are linked together using the Slingshot interconnect. And that's how you access the power of the system, is by running things in parallel and using the interconnect to talk between them. When the final system's available, like I say, hopefully later this year, it will have over 5,500 compute nodes and almost 750,000 compute cores. And amongst them, there'll be some nodes that have higher memory, double the amount of memory of the standard nodes with 512 gigs per node. As I said before, access to the compute nodes is controlled by the Slurm batch schedule. We'll talk more about that after lunchtime. It supports batch jobs where you submit them, and then you can log out the system and go away, go about your day, and come back once the job has been scheduled and complete. Or you can also run interactive jobs through the scheduler, and we'll see that after lunch when we try running some jobs, which give you direct access to a compute node, so you can type commands there and do that and use them as if you would any other command line access. As there's a comparison here with the previous system, Archer, which we can take away now because Archer's been away for a long time now, really. But this is sort of what we described about the compute nodes here, the type of processor, cores per node. I haven't mentioned the numinous of the system, so that's NUMA. If you haven't come across the term, is non-uniform memory access. So generally on HPC systems, rather than having 128 cores, all with equivalent access to all of the memory on the compute node, it doesn't quite work like that. The nodes are actually subdivided down into areas that have uniform access to memory, and then if you have to go outside of that region, then access to memory is a bit slower. So on ARCHER2, there are 8 NUMA regions per node and 16 cores in each of those NUMA regions. So those 16 cores have fast access to their own memory and slower access to the memory that's on other NUMA regions on the system. What this means in practice is that if you are running jobs that use both MPI processes and OpenMP threading, you have to be careful about how you distribute the processes and threads to make sure that they're aware of this NUMA setup on the nodes. Again, I'll mention a bit more about that when we talk about the scheduler and running jobs later on today. And they have 256 gig of memory, the ones we have now, and in the future there'll be a smaller number of them with 512 gig as well. And we talk about the memory bandwidth and interconnect bandwidth as well there, but I'm not going to go into any detail about those at the moment. As well as the compute resources, there's the storage resources. So when we logged in, we saw that I had space on the home file system, and that's where my home files are. I don't have anything there at the moment. Well, that's not quite true. I probably have some hidden files. Yeah, so bash and various other bits and pieces. So that's where I'm dropped when I log in normally. As I've said, the home file system is only available on the login nodes. It's not available on the compute nodes. And there's also a work file system, which I'll talk a bit more about in a moment, and Rdf as a service file systems, which are a bit specialist. I'll mention them briefly, but we won't go into any detail about them. So the home file systems, where you get in onto the systems, are really designed for storage of critical source code and data. They're lower capacity, but they are backed up regularly off-site for disaster recovery purposes, and they support the recovery of data that's been deleted by accident. So if you delete a file on home, you should generally, unless you've left it for a very long time, be able to go back and find the file. Or if you overwrote a file that you by mistake, you should be able to go back and get the old version of it. As I said, they're reduced capacity, so there's only 1 petabyte for all use to be split across all users and projects and accounts on the system. So there's not huge amounts of space, but the space that is there it should be used for things that are really important, and you don't want to lose. Everybody has their own directory on the home file system, and generally it's at this sort of path here, which you saw on my terminal. Mine was at home project username. That's the general one. In reality, it's home project subproject user, but a lot of projects like this training camp don't use subprojects. So, as we've seen here, if your username is a user and your project is T01, then your home directory is there, will be there. One thing that's unfortunate about the terminology, I think, but to try and keep in mind, is that home file system and home directory are not synonymous. Okay, so the home file system is the storage system on ARCHER2, which uses for critical data, and it's where your home directory is located. The home directory is a Linux concept of a directory you're placed into when you log in, and it's stored in the home environment variable, and you can also get it through cd tilde. So if I go and echo the home environment variable, you can see it points to that directory in the home file system. Home file system and home directory are not necessarily synonymous. Safe, we'll talk about later on in the day about how you can view what you're using and get reports on your usage through Safe. You can view a home file system quota through Safe, and there's some instructions on how to get there. We'll look at that a bit more detail later on. The data in Safe on quotas and usage is updated on a daily basis, or at most twice daily. So the information might not quite match what's on the system if there's been a very large change, what actually exists on the system. There's been a very large change, but Safe will catch up. And there was a brief mention of sub-projects, and I said they're not used in this training course. If you're part of a very large project in ARCHER2 or one of the high-end computing consortia, they often split their resources into multiple sub-projects, and they tend to have and they always have identifiers which are prepended by the main project ID. For example, if there was an RSE subgroup of T01, you'd end up with T01. A dash RSE is the sort of subspace as the subgroup, and you'd have a corresponding directory structure that looked like that. Generally, if you become part of a sub-project or you get access to a sub-project, your home directory, your Linux home directory, doesn't get updated. So you must actually manually change directories when you log onto the system, or change the ownership of files to make use of this different storage quota when you get onto the system. Okay, so your home directory, the Linux concept of home directory, tends to stay the same, even though you may have multiple spaces and multiple quotas in the home file system. And the home file system, as I mentioned, is fully backed up. Full snapshots are taken. We take them weekly for each of the past 2 weeks, for daily for each of the past 2 days, and hourly for each of the last 6 hours. And you can always go and find the snapshots these paths. So if you've deleted a file or overwritten a file by accident, you should be able to go get it back. Depending on how far back it was overwritten, you can access the right snapshot and then go and get the old copy of the file that was backed up. Okay, so that's the home file systems. The work file systems are generally where you will do most of your work when you're on the ARCHER2 system, and that's because it's only the work file systems that are visible on the compute node. So any jobs you run, any computational jobs, any work you actually do, has to write to the home file system. Sorry, to the work file system, not the home file system. You also get an error from Slurm if you try to access files that are on home file system on compute nodes. It'll just say the file doesn't exist because it doesn't on the compute nodes. If you try to submit a job from the home file system, you get an error from Slurm saying you're submitting from the home file system. That's probably not what you want to do because it doesn't exist on the compute nodes. There's much more capacity available on work. There's 14.5 petabytes, which is split across all users, projects, groups on the system. And it's also a parallel file system based on Lustre. What this means is it potentially has very high read-write performance, especially if you're reading and writing in parallel, especially compared to something like the home file system, which will be much slower, which is one of the reasons it's not available on the compute nodes. Your location of your work, your directory on the work file system, is an exact analog of where it is on the home file system, but with work at the front instead of home. So the one for me would be /work, and then the rest of this stuff for my home. So I can copy and paste that onto the end, and there'll be nothing here either. But I am now on the work file system, and so any data I write here will also be visible on the compute nodes as well as the login nodes. You can see that if I scroll back up to the picture here, you can see the work disk is shared across the login nodes, data analysis nodes when they arrive, and the compute nodes. Okay, so that's where you'll do the majority of your work, work and usage when you're using ARCHER2. Well, a really common error people say is this file not found. And when you go and log into the login node, you can say, well, the file's definitely there. That usually means you've done something with the home file system, if you get that sort of error on ARCHER2. As for home, you can look at your work file system use and quota through SAFE, but you can also access it directly on the file system, so you can get a much more up-to-date report. So, for example, for this project, which is TA05, I can type the LFS quota, and then the options minus H to make it human readable. That gives it in human readable units rather than just bytes, which is quite hard for us to read. I specify the group. So the second option is the group, and in this case it's TA035, and then it's work TA. I only need the first bit of the file system to tell me what the quota looks like. Oops. I've done something very silly. I've added a G to the end of it. Okay, so you can see here that so far the project TA05 has used only 64K, and its quota is 100 gigabytes. Okay, and there's only 16 files there at the moment, so you can get that sort of information directly off the system. Unlike home, we have to go to the safe, and it might be slightly out of date. You can also do the same for user if there's user quotas. There aren't any user quotas for this project, so it's not very interesting. But I could substitute in here my username, which was RTN, and I could change that to U. And you'll see there, sorry, excuse me, the quota is 0 and the limit 0, which means there's no quota set for users. And the system, the quota is all controlled by the project and the group. Okay, that's up to the individual project manager, PI, of their projects. They can set user quotas through the safe if they want to do that, sort of thing. But for this project, which controls the course, we haven't done that. Okay, one further topic around file systems is often people want to share data with other users on the system. Now, you can't just do this ARCHER2 by setting permissions of the files to be world readable, because lower down the file tree, there's restrictions on visibility that you can't change. Okay, so we create two different shared directories for people to use according to their project. There's one which is just one level down from here. So if I go down one level, these are all the people who are in this have signed up for accounts in this project. But there's also a shared directory, and that lets me share data just within this project, okay, between myself and the other user accounts listed there. If I want to share to general ARCHER2 users, not just within my project, but out with my project as well, then I go down another level to work TA05, and there's also a shared directory there. And that one allows me to share data with other users of ARCHER2 who aren't in the same project as me. Of course, you can still control access by setting file permissions in there in the usual Linux way, but they're the two different shared locations for sharing data. with people. But then it depends whether you want the data to be restricted just within your project or whether you want it to be visible to everybody on ARCHER2. And these sharing directories exist on the home file system as well, if you want to use them there. So you can use it on work or home, depending. Generally, people, I think, use it more often on work because you tend to have a bigger quota there, and that's where people are actively working with their data on the file system. So Zora asks, what's if you want to share with only one user? That's not possible. Okay, the only options are to share with a project, or the one way of doing it, I think, the only way that you could do that is you could set up a subgroup with just you and the other user in. If you have the PI or the project manager, and say you could set up a subgroup with just you and that one other person in, and then you'd get an extra shared directory that just you two could see because you'd be in the same group. But it's a bit of a hack workaround. But generally, Unix Linux file permissions are not very flexible in terms of allowing granularity of sharing data. Okay, they don't allow, and the way the work file system set up and Lustre on these big systems, they don't support access control lists, ACLs, which are the sort of the alternative technology for giving access to particular people to particular files and directories. Okay, so that I think is that's a quick overview of the hardware. We talked about the compute hardware, the processors, and the memory, and that sort of stuff, and the storage systems as well. I said I'd briefly mention the RDF stuff. There are also some RDF file systems which are generally longer living and persisted from, for example, the previous National HPC service Archer to ARCHER2. They're only accessible to particular projects. So if you happen to be in one of the compute consortia, then there are also these RDF file systems. You can find out more about them on the in the ARCHER2 documentation. They're not accessible from the compute nodes. Again, they're only accessible on the login nodes and the data analysis nodes when they come online in the future. And they're designed for more long-term storage of data in a fully backed up, in a sort of disaster recovery backup way. But if you have questions about those, please ask, and I'll do my best to answer them. But I'm not going to go over them because they're not of interest in general to most users here. So that's all the hardware. In terms of, I'm just briefly going to mention what the system software is, and then we're going to look at software in more detail. When system software, ARCHER2, as you can see, is Linux. It's Linux is actually what's known as the HP Cray Linux environment, or CLE, which is based on SUSE Enterprise Linux. As a service, we only officially support the Bash shell for interactive access, though we do have some users who use C shell-like alternatives like TC shell, and sometimes it does just work, but in general we only support Bash. We have had some people, I think, use ZSH as well and use it successfully, but as I say, we only support Bash officially. The scheduling software itself is called Slurm. We'll talk about more about that in detail after lunch. And as well as the hardware and the sort of system software, the operating system, HPE supply what's known as the HPE Cray programming environment, the PE, which contains various bits and basic pieces of software that people use to make an HPC system work. So this is things like compilers, so that people can build their programs on the system. So we support GCC, the GNU compiler connection, and the HPE Cray compilers, that's the Cray compiling environment, CCE, and the AMD compilers, that's the AMD optimizing compiler connection, AOCC. In terms of parallel libraries, there's a typo there. It says MPE Cray MPI, and we should say HPE Cray MPI, which is a variant of MPICH, which is used for message passing. There's also OpenSHMM and the Global Arrays Toolkit. Various scientific numerical libraries, the standard BLAS, LAPACK, SCLAPACK stuff is part of HPE Cray libsci. Then there's also FFTWs, HDF5 and NetCDF IO stuff. Some debugging and profiling tools. And there's also, probably of interest to people generally, an optimized Python 3 environment. So this allows you to run distributed Python tasks using things like either MPI for Pi or Dask. and also includes NumPy and SciPy linked against the optimized numerical libraries to give good performance. And there's an optimized R environment as well for data analysis, and that includes the parallel package to be able to distribute your work across multiple processes on the system, because there's so many processes per node, and parallelism is really what the system's about. So there's quite a rich environment that's provided by default by HP Cray as part of the system. There's some chat about the differences, be it from Archer here, which aren't interesting probably anymore really, because the Archer system's been gone such a long time. But on top of the HP Cray provided software, ourselves at EPCC in the Computational Science and Engineering team install and maintain a wide variety of other bits and pieces of software for modeling and simulation and scientific and numerical libraries, various other bits and pieces. So some examples of the things the type of things we build and maintain in the system are molecular modeling sorts of packages such as CASTEP, ChemShell, CP2K, LAMPS, and WChem, OneTip, Quantum Espresso, VASP, some engineering ones, Code2Turn, Phoenix, OpenFoam, biomolecular modeling, well-known packages, GROMACS and NAMD, Earth systems modeling, so the UK Met Office Unified Model, ELFRIC will be coming in the future, which is a replacement for the Unified Model, NEMO, the ocean modeling software, and MIT GCM, which is an Earth systems model used particularly with oceans. I'll answer the question in a minute. And then there's various scientific libraries and various other bits and pieces of software tools. So Damal asks about lights, which is some sort of derivative of lamps. So that's not an officially supported package on the service. What I was going to say is, as well as this software, we also help users install other software if it's not in the list. So people are always able to install software themselves in their own work directories, for example, so they can use it on the compute nodes. And the CSE team provides support to do that. So if there's a piece of software that's not there and you want it on, then we review actually the demand from users for various bits of software, and we may add additional centrally supported software if there's enough demand for it. But whether there's enough demand or not, we'll always help you get your own software up and running on the system. So you can just drop us a line at the service desk. They'll give you access to the experts at EPCC who know about compiling the software and how to use the system, and they can help you get it up and running on the service, so that you can get up and running with your research. So because we recognize, right, that we can install and maintain a certain amount of software, but we definitely can't maintain and install everything that users will ever want, because the amount of software and the software out there is just too wide for us to be able to support it all properly. But we can always offer help to get you up and running on the system. So we can do that via email, or even if you want a dedicated session with people, you can get in touch with us and we'll get the expert to call you back, and you can screen share and work together to get things up and running. Sometimes some of these softwares are licensed software. So, for example, VASP or CASTEP or OneTep, for example, are licensed software. They're not open source and freely available. We don't provide any licenses for any of this licensed software. We do install and maintain it, but if you want to use those pieces of software, you have to prove and bring your license with you to ARCHER2. So, for example, to use VASP, you have to have registered for a VASP license already. And then you through the safe you say, can you please give me access to VASP? And we check the license against the VASP license database and make sure you're authorized to have access, and then enable access on the system. And I'll talk a bit more. I'll just mention that briefly in the next section as well. So that's an overview of the system and what's there by default. Before I move on to the next session before lunch. Oh, sorry, I should have said also there's more information on the software available on ARCHER2 in the ARCHER2 documentation. There's a list of maintained and how to use it, example job submission scripts, and some of them also have information on how to get best performance and things like that. And we also support the use of containers on the system for both single node and multi-node, for example, parallel MPI jobs. So if your workflow is already containerized, say using Docker or already into Singularity, then you can use Singularity to run those containers on the ARCHER2 system. So that's a brief overview of the hardware, the file systems, and the system software that's available on the system. Now, before I move on to the next section, where we're going to talk a bit more about the software environment itself and how you access these different softwares and switch out different versions. Do people have questions about what I've talked about, or anything they want clarified before we move on? Okay, I'm not seeing anything, but if something occurs to you, please just stop me and ask. Oh, how to get access to licensed software. I will talk about that exactly in the next section. Okay, how that works. Okay, so there's, okay, so we talked about all that. Let me skip on to the next section then. We'll talk a bit more detail about the software environment. So what we're going to talk about here is what does it actually look like? You know, I talked about what was available a bit in the last section, but what does that look like in practice, and how do you access the software? How do you find out what's available, and where can you get help, which I've already mentioned a bit as well. Okay, so ARCHER2 uses software uses the environment module systems to provide access to the different software versions on the system. Because the modules available and the versions available will change across the lifetime of the service. You know, and these software modules are provided both by HP Cray, and we'll see, as I mentioned before, they provide some things as part of their the Cray program, the HP Cray programming environment, and also by the CSE team at EPCC. So let me go back to my home directory here on the home file system. So when I log in to ARCHER2, my environment is already set up with some software modules, and all available, and all the things about the software modules are available through the module command. So when I first log into ARCHER2, I can see what modules are loaded for with module list. So you all can log into ARCHER2 now, and you can follow on these commands and try these things yourself and explore it yourself as we go along as well. Okay, so I type module list. It shows me what software is already loaded into my environment, and actually it's quite a large list on ARCHER2 compared to many other HPC systems or any other HPC systems you might have used. And that's because the Cray programming environment loads quite a lot of stuff by default. So all these things that are prepended with CPE or Cray PE or Cray are all things that are loaded by the Cray programming environment, the HP Cray programming environment. So there are various bits and pieces here. So you can see that I mentioned there was various compilers. You can see that the default compiler loaded is CCE, which is the Cray compiler environment. You can also see that MPI is already set up with this Cray mpitch environment variable, and that you also have access to the basic numerical libraries in Cray with the Cray libsci module. And that's the thing that has like BLAS, LAPACK, SCALAPACK in it. There are a few other bits and pieces. Some of these ones are system modules that make available various things like the fabric that control the interconnect communications, and XPmem, which provides an optimized memory access. Okay, so that's what we've seen there. And you can then add other software using the module command as well, which we'll look at in a moment. But one thing to note is that unlike many other HPC systems you may have used, you do not generally use module purge command. That command is still available to you. So if I do module purge and then module list, okay, you can see that no module files are currently loaded. Unfortunately, that means that you can't use the system correctly now, because it needs some of those modules loaded to be able to make the system work. So if you do this by mistake, then the simplest way to get a reset is to log out and log back in again, and you'll get back to the state you were in before. So I'm going to log out, and then I'm going to log back in again. Hopefully I typed my password right. Oh, there we go. Did I get it right that time? Yes, I did. And so I've logged out, logged back in again, and it's reset my environment back to the module list we had before. Okay, when we want to change the setup, we'll generally use module load or module restore commands instead. Okay, so given that that's what's loaded by default, how do we find out what else is there so that we can add it into our system? Say we want to do access GrowMax, for example, or something like that. Well, to see a list of everything that's available, we can do module avail. And that will show us all the various modules available. And they tend to be categorized into slightly different things. So you see these sections with different things and categorized in. So there's some Python environments for running things like TensorFlow and PyTorch. There's utilities such as CMake, which is used for building, TCL, various other bits and pieces. We'll use one of them later, which is called XT-High. There's libraries, scientific and performance libraries, so things like PETC that aren't provided by HPK by default that we've compiled ourselves. Things like PETC, Trilinos, Parmetis, Intel's math kernel library, MKL, things like that. And then there's some applications which tend to be modeling simulation outputs. So I mentioned CastEp before and CodeSaturn. There's GrowMax, various versions of GrowMax available. There's a couple of versions of OneTep. Lots of versions of different versions of RASP available on the system, for example. And then we keep scrolling down. We'll get to the stuff that's provided by HP Cray. So this is the standard HP Cray stuff because it's all prepended and mostly prepended with Cray. So they have things like NetCDF and HDF5 libraries and some other bits and pieces, FFTW, Global Arrays Toolkit, GA. Anything else that's particularly interesting? Not really. Different versions of NPI available, so there's quite a few things of them. And then there's some other bits and pieces that we're not going to talk about in this course at all. So a huge pages library and the various different compilers and some other system stuff down the bottom that we're not really interested in right at the moment. So there's a lot of software modules available. At the moment, the list is just about manageable to be able to scroll through and find what you want. But if you wanted to just trim it down, you can give the name of the type of software you want and you see a list of that. So for example, if I was interested in what version of GrowMax are available, I could just do module avail GrowMax and it'll show me all the different versions of GrowMax that are available on the system. Okay. So feel free to, once you're logged in, explore and have a play around and see what modules you can see there. So I'll scroll past all this output. One thing you will notice, and you can see it there with GrowMax, is what happens if I don't specify a version to load. Then it chooses a default version. And you can see this thing in brackets tells you what you'll get if I just did something like module load GrowMax. If I just did that and didn't specify the particular subversion of it, then I'll get the default version, which is 2021.2. Yeah. Okay. So I do that. It does some stuff. We do module. Oops, I can't type. Module list, which will show me what modules listed. You can see as well as the stuff we had loaded before. I now got GrowMax loaded there as well. You can also find more information on a module with the module help command. Okay, so that tells you a bit about. But if you load GrowMax, it tells you, you can access the GrowMax single and double precision version executables using the gmx_npi, gmx_npi_d commands, and so on and so forth. There can't be multiple default versions, and that's not allowed by the module system. Okay, so when you have a module name like GrowMax, there can only ever be one default. Now there is the chance that somebody, sometimes you get this, the case that somebody set up the module system and has not specified a default. Then it's a bit more random about which one you get. It depends a bit on the system whether you get, for example, the last one in the list or the first one on the list. But it's not well defined if there's no default specified. So if you see a module and there's no default, then you can. You're much better to. Sorry, let me just module move GrowMax to get rid of it again. Yeah, okay, so but the multiple default versions of VASP there are two separate versions. There's VASP/5 and VASP/6. So there's a default VASP5 and a default VASP6 there. Okay, because there's two layers on the VASP modules. There's a VASP/5/something and a VASP/sys/something. Then if you do module, well, let's see what happens if you do module load just VASP. Okay, so it's giving me the last one of those two. It's giving me the VASP6 default if you just do module with VASP. So if it's like that, you need to specify whether you're using VASP5 or VASP6. Okay. So we talked about module help, and they can show you more information on a particular module. I've actually showed you the module load command already. I loaded GROMACS and showed you that. And that bit, once I've, sorry, let me module load GROMACS again, because GROMACS is a good one because it's open source, so we don't need any licenses to access it. So then I should have the GMX command, for example. Okay, oops, GMX. Let's go MPI. There you go. So the GROMACS MPI version, it tells you that because I've loaded the module, it now knows that that's there. If I, sorry, don't exit. If I module remove GROMACS and then say which GROMACS MPI, it says it's not there because it doesn't know modules, but it doesn't know GROMACS there because I haven't loaded the module file. Okay, so there's various ones available. I think it's set up here. Just let me scroll back up a moment. Okay, yeah, we talk, and we're going to talk about licensed software in a minute. If you wanted to, there is also a module switch command. You know, say you had a module GROMACS loaded, and you actually wanted to, you realized you'd loaded the wrong one by default. So let me load GROMACS again. So that's loaded the default GROMACS, which is 2021.2. But what if I realized that I actually wanted the older version of the software, say 2020.3, then I could do module swap GROMACS for GROMACS 2020.3. So I don't need to specify the version I'm swapping from because there's only one loaded in my environment at the moment, so it doesn't matter. If I do that, so you can see now the GMX MPI is the older version. It's the 2020.3 version. I've swapped that out. If I tried to just do module load, the newer version now, hopefully it will tell me it's a conflict. I haven't tried this, so yeah. So it can't load another version of the module because GROMACS is already loaded, and it wouldn't know which command, which version of GROMACS to interact with. Okay. Sometimes you've seen the module command spit out quite a lot of output. So you know, if I get rid of GROMACS and then I'm going to module load. If I give the -S option and I wanted to load VASP, you'd get no output because S just means be quiet about it. Okay, so the module command is how you access different bits of software. Typically, once you've loaded a module, and the software is available wherever you've loaded that module. You know, so if you load the module on the compute node and then submit a job, and then write a batch script and submit a job, as we'll see further, then it's not going to be available in your job. You'll need to issue the module load commands in your job script as well. We'll talk about that in a minute after lunch when we talk about you know, submitting jobs and running jobs and all those sort of things. But you generally have to load the module wherever you want to use software, be that in an interactive session, be that in your job script when you're on the compute node. So there was a question earlier about licensed software and how you access licensed software. So we install some software, so for example, VASP's a good example. And you can load the module here. You could see I could just load the module. So where was I? So I've now loaded the VAS6 module. So actually, let's see what it says about that. Let's try that. Okay, so if I look at the help for the VAS6, it tells me the executables should be called things like VASP_std, VASP_gam. So it tells me that there's no VASP available, even though I've got the module loaded, and that's because it's licensed software, and you can only access the executables once your account has been approved for access. So you can see that it's looking in the right place, which is this directory for the VASP executable. But if I try to do an ls on that directory, I can't open it because it's permission denied, because I don't have access to VASP on the system. So the way this works is that we don't provide the software licenses. Okay, the service does not do that. So you know, because you've got an account on ARCHER2 does not mean you can use VASP. Okay, you have to also have a VASP license, for example, or whatever a piece of software you want to access the license for that. And the way you do it is you can do it through safe. So let me get up my account in safe. So go up. Actually, there was a link there, wasn't there? Log into safe. So I go there. Let me make it a bit bigger. So I have a few more menus than most people because I have administrative access to the safe. But in general, and I have a lot of login accounts. Let me go and look at my login account for this course. So this is my login account, and access to the machine, blah, 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 blah. Various bits and pieces about quotas. We'll look in this in more detail a bit later on, my SSH key. There's a button here that's request access to package. And if I click that, I can select from this list which package I want to get access to. And if I choose, say, VAS6, then I get a form with some descriptions and some notes there. So it says, you know, please supply the email address that was registered for VAS6 access with the VASP team. First, my materials design, and let us know so we can contact you to ask for a copy of your license agreement. So you'll generally ask, it will generally ask you for information to allow us to go to the team that look after that licensed software to verify your access to that piece of software. Okay, and it just says what account. So what will happen is you fill in the information there, you say go, and it'll come into the service desk, and they will go and check with the license team. And if you've already got a VASP license, then we set it up on ARCHER2 so you can access the VASP software. The same is true for all the other licensed software that was there. And does that, I think it was Sasha who asked that, does that provide the answer to your question about the licensed software? Okay, fine. So there's not a huge amount of licensed software on the system at the moment. Let me do module avail again and see what's there. So if we go down to the actual software packages, out of this list of software here, the ones you need a license for at the moment are CASTEP, OneTep, and VASP. I think that's it. Oh, no, where's the other one? Is ChemShell not there yet? Okay, so when ChemShell appears, there'll be ChemShell as well. But of all that software there, there's only really CASTEP, OneTep, and VASP that's licensed software. The rest of it's open source software, is usable by everybody who accesses the system. They can access the software with no problem whatsoever. So although they tend to be, particularly VASP is a very heavily used package, they tend to be popular bits of software. The amount of licensed software on the system is actually quite small. And most of the software there is just available for everybody to use as much as they want without having a license. Okay, so that's licensed software. We talked about the modules that are loaded by default. We've talked about how you load additional software modules and how you switch them and how you get back to the environment, which is essentially log out, log back in again. Is to reset your environment. Some people sometimes add module commands to the startup scripts. So things like bash bash RC and those sorts of scripts, they'll add module load commands there or module swap commands there for convenience reasons. Okay, typically we would advise against doing that. The reason we advise against it is it can make it very opaque when things go wrong. So it's fine when everything works, but as soon as you've got an error on as soon as you run into an error and you email the service desk, if they don't know that you've got these additional commands in your profile scripts, then it can make it much harder to debug the problems that you're seeing. So generally, we would advise people not to do that. You can create what are called module collections on the system, which is once you've loaded an environment and set up all the modules. So say I wanted to create I mean, it's a really silly thing, but say I wanted an environment for plotting in Python. Okay, so there's a Python plotting module that includes things like matplotlib and those sorts of tools, and it's also got Seaborn in it. So to do that, I would need to module load create Python to get the base Python environment, and then module load Python plotting. Okay. So I've got everything there, and so now I should be able to type, for example, Python and from matplotlib import pyplot. Hopefully that should just work. It's away working. It's a little bit slow because everything's on the work fast, but it's done. Okay, so that works. So I've got an environment that potentially allows me to plot there. So rather than having to issue those two commands, which are maybe not much of an overhead, but it's a little bit of an overhead, I could save my current set of modules, which is the standard set plus the two Python ones there. Oh, I've got VASP in there as well. Let me get rid of that, because that would complicate things. Okay, so I can now save this list with module save pyplot. Let's give it a name. Okay. And there's a command module save list, I think, that shows you which environments you've got saved. So these three ones, the plugin ones, are ones that are set up by default by HP Cray. They're not of interest for this course at all, really. They're even more interested if you're compiling your own codes, but that's not what this course is about. But there is the pyplot one there. So now if I exit and log back in again, hopefully I can type my password correctly. So I've got module list, the standard one, because I've logged out and back in again. I've got module save list. You can see my pyplot ones there, still there. So module, and not load this time, but restore to get back a saved set. Okay, and it gives me some information about what it's doing. If I do module list, I'm back to exactly the same setting that I had before when I save the list of modules. So rather than put things in your initialization files like bash RC, it's much safer to save list, to save these collections and then use the restore command to get them back. If you want to save sets of modules and be able to get back to a particular environment that way, that's definitely a preferable way to do it on the system. And it's actually a bit more powerful as well because it allows you to switch between saved environments more quickly, because I can get back, I can load it, I could save another one and just module restore and it would get me straight back to where I was before. Okay. So how can you request the installation and use of open source software? So, okay. So that was my next step. So as I said, there's more information available in the documentation. Let me show you. I'll quickly show you the documentation because it is useful to see this. In the menu here, there's information down here about research software, which is the different software packages installed, and you see that's the current list there, and you can go and look at, for example, the VASP one. Tells you a bit about VASP, has some useful links. tells you how to use VASP and how to request access to it because it's licensed software, how to load it, how to use VASP transition tools, example job subscription scripts, information if you want to build your own version of VASP. Some people do because they make modifications to the source, or for some reason they want to maintain a separate version, and some tips on how to get the best performance of VASP on ARCHER2, and some performance data as well for some sorts of benchmark use cases that might help guide you for settings for the software. So that's fine for installed software. If the software has sessions, that's there, the software you require is not currently available, or you have, then how do you get that on the system? Well, as I said earlier, we do monitor requests for software, and if there's enough demand for a particular software package, then we may move to install that centrally for everybody, because there's obviously lots of people want it, and that's great. But even if that's not the case and there's not huge demand, say you're using a software package and it's maybe only you and a other couple of users who are interested in it on the system, then if you email the service, if you get in touch with the service desk, then they will help you install it in your own space, okay, and help you set it up so you can use it. So say you had a piece of software, what was it, Lights was mentioned earlier, then you could get in touch with us and say, I'm just going on to ARCHER2, I want to use the Lights software. I don't quite know how to get making it available. Can you help me out? Then we'll be able to say, well, look, we'll download a copy of the software ourselves. We'll work through the installation and do some tests, and then we'll send you back instructions on how you can install it in your own local space for you to use, even if we're not going to install it centrally. Okay. So we'll support any piece of software on the system. The central installed route of software is really only for software that has very high demand, and because we have to maintain that then and install new versions and all those sort of things. But if you have any question on software and you want any other piece of software, help installing any other piece of software, then we can provide that. And people are always free to install whatever software they want in their own file space, as long as it's for a legitimate use of ARCHER2. For example, we may not be very keen on people installing Bitcoin mining software on the service, but if it's a genuine research use, then you can install whatever you want and use it on the system, and we'll help you install it and get it up and running. Okay, so like I say, anything, even, and also if you're having trouble with any of the installed software already, or you can't, it's not quite working as you expect, or something's wrong with it, or it hasn't got an option that you wanted built into it, or something like that, then just drop us a line, and we're always happy to help out. That's our job here, is to help people use the system and do their research on the system. So we don't tend to tell people to go away. We tend to try and help them out to get up and running on the system as quickly as possible. Okay. We had a few questions there about software. Does anybody else have any questions on the software and ARCHER2 and installing software and maintaining it, switching it, and various things like that? Well, people, how to access the GPUs. Okay, so there aren't any GPUs on ARCHER2 at the moment. It's a CPU-only system at the moment. So there are no GPUs there. As part of the full system, there's a test part that's coming that's going to have a small number of AMD GPUs available for people to use as a test bed. They're not going to be for production use because there's only a very small number of them, but it's to allow people to explore the use of AMD GPUs for their software and their research. They'll come with a full system later in the year, is the plan. And of course, most people who use GPUs typically use them either, well, in terms of HPC use anyway, it's mostly been NVIDIA GPUs. So it's either been via CUDA, or people have used them for machine learning, and then you use a framework such as PyTorch or TensorFlow or something else on them. We haven't got the AMD GPUs yet, so we haven't had a chance to play with them. Of course, they won't support CUDA, and they will support HIP ROCm, which is the AMD equivalent of CUDA, and there are tools out there to help you convert from CUDA to the AMD frameworks. And we're assuming that there'll be support for machine learning frameworks such as PyTorch, TensorFlow, etc., etc. But we haven't had the chance to test that in practice yet because we haven't had access to GPUs yet. So there will be a very small amount of capability. If you want large capability with GPUs, then there are various systems out there, other national HPC services in the UK that aren't the sort of large-scale supercomputer like ARCHER2. For example, also at EPCC in Edinburgh, there's the Cirrus system, which is at Cirrus. If you look at cirrus.ac.uk, that system has a large number of NVIDIA GPUs available on it. So maybe that one of the, if you really GPU centric, then one of those other systems is probably a better bet than going for ARCHER2, which is really a CPU focused system. Okay. So what else was I going to say about software? I was going to say something else, but it's gone out of my head right now. If I remember later on, I'll go on. So we're a little bit ahead of schedule right now because I think the next section is the lunch break. And I think rather than start on the next session and dash on now, we've probably got, we were supposed to have 20 minutes until the lunch break was started. I'm more tempted actually to give people a bit of a longer lunch break, especially as I'm aware that, you know, online learning and online sessions, it's quite hard to keep focused for a very long time. And it's better probably to have the longer break and come back more refreshed than to push on now, get halfway through and all the mental fatigue associated with that and pick it up again. So what I'm going to say is that we'll start again as scheduled in the schedule here, because I said the lunch break was going to be fixed in time. So that'll be at 1:45 UK time, 13:45. That obviously gives you an extra 20 minutes for lunch on top of the hour that we had, but hopefully that gives you a chance to get out, maybe get some fresh air, or, you know, stretch your legs a bit more, focus on something else, rest your brain a bit from online learning because it's a bit full on. And then we'll start again then. What I will do is I'll stick around for the next 10 minutes or so. So if anybody has any questions or, you know, has any problems or wants us something specific that they didn't think matched onto the general chat very well, then I'll hang around here and I'm happy to answer any questions. Yeah, so Alexandra says, I see the session is being recorded. Do we get access to recording after the workshop? Yes. So there's usually what we do with the recordings is we take them and we do a bit of processing to remove any personal details from people as much as possible, so that, you know, they're not available, and then they go up on the ARCHER2 YouTube account. So there's a bit of processing involved, which means it's not instantaneous straight after the workshop. So it'll probably be a few days after a few days, or maybe a bit longer, depending on how busy the training people are at getting the recordings processed. But yes, you'll be sent a link to that as well once the recording's up, so you can always come back and watch it again. And the materials website here, this website, which is on GitHub Pages, and that stays forever, so that will always be there, and you can always access it if you want to go back through and work your way through step by step as well. Okay, so if you want to go off, then please feel free to go, and I'll see you back here at 1:45 UK time. If you've got any other questions or things you want to ask about, or not general questions on material, questions more general about HPC and ARCHER2 and things like that, then I'm asked to hang around, and for a little while, feel free to ask me. So ask, how can we use this temporary username? I mean, on how many calls? Okay, so you can submit whatever job you like, right? What we'll do this afternoon when we submit jobs is we'll submit into a special reservation that's been created for this course, which has a limited number of nodes available. Okay, but that doesn't mean you can't submit to the general queues. So, you know, if you wanted to try and run a 900 node job, which is just a minute, I can't do that sum in my head. So 115,000 cores, then you could do that. There's no limits on these accounts. Oops, there's no limit on the account other than the amount of CPU time allocated in the project, and we can always top that up if people need a bit more. So, you know, you can use as many cores you like. You don't have any limits that any other user on the system. You're only subject to the same limits as any other normal user on the system.